All right, this talk is called Rethinking Errors, Learning from Scala and Go, and our speaker is none other than Bruce Eckel.
Okay, so to the content. So this presentation, it will be on the slide deck as well, but if you want it right now, this second line is where you can go and get it if you want it immediately. So what I'm going to be talking about is a little bit of error reporting history and a new and simple approach, which is basically you just combine the return object and the error object, and that way the caller is forced to pay attention to it. They can't just assume that the return object is, what they get back is always good. And then I'll look at how it works in the Go languages and Scala language. And a little plug, just finishing this book, which interestingly enough has the same mid-century modern theme as the Python conference this year. And then I'll show how we would do it in Python, taking a couple of different approaches. So it's quite simple and straightforward, but I think quite useful. And I'll also mention that C++ is even moving in this direction. So it's one of those things that it's taken us a long time to see the obvious, but once you see it, you go, oh, that is obvious. So the problem I'm looking at is that not buggy functions or system reliability problems, but bad inputs. So if you get bad inputs, you get bad outputs. How do we report that in the chain of calls that we give? Because if you have bad error handling, you're going to get bad programs. The main problem that I found from my own experience as a novice programmer is novice programmers. They come in and they have this faith in the language and or compiler or something like that, and they go, well, it'll tell me if something is wrong. And that's how I came in. I thought, because I initially started programming in Pascal and C, and it seemed like those languages would, tell you when something was going wrong. In particular, C++ would do a better job of that. And so I kind of thought, well, it'll be fine. I'll just take the result and run with it. And this attitude can persist for a long time, and it certainly did with me. It wasn't until I spent 8 years on the C++ Standards Committee, mostly as a further form of education. I wasn't as, I was surrounding myself with smart people, basically. And it wasn't until they introduced exception handling that I really started looking at the issue. In C, they tried a bunch of different experiments and nothing really worked. Initially, it was just, let's return an unlikely value. So if you're expecting a positive value, we'll return -1. They tried setting a global error flag. So if another function sets a global error flag, you got to make sure you check it before you call any other functions or anybody else calls any other functions. That didn't work so well. There's a signaling mechanism. If you set a handler, you could raise a signal. Most people, that seemed too complicated for them, so they didn't do that. And then there's the idea of a non-local go-to, the set jump and long jump mechanism. So none of these really worked, and you could, in this case, I could just pretend that, oh, I'll call the function and it'll give me what I'm looking for, and I don't really have to worry about whether the result is good or bad. C++ introduced exception handling, which, as far as I could tell, because I did a bunch of research on exception handling when I wrote Thinking in Java to try and explain why checked exceptions were not such a great idea. So I researched back, and it appeared to have appeared in the 60s with Barbara Liskov, and most of that was with Lisp. But I couldn't find it going back any further than that, or at least the papers that I was looking for. So C++ introduced the idea of exception specification. So you have in your function signature what you're passing to it, what you're returning, and what exceptions it might throw. And this seemed like a good idea, but they weren't enforced, so it was really just an informational thing. And the structure was try and catch and things that you're familiar with if you've worked with either Java or C++ or Python has similar structures. And then finally for doing cleanup. All right, so it was a step in the right direction. It emphasized error handling. And in Java, they took, well, after roundly declaring that C++ was a terrible language, they took most of the things from C++, including exceptions, and except that they said, well, exception specification should be enforced, and so they introduced checked exceptions. And I don't think, and I've watched for this, I don't think anybody has reproduced the idea of checked exceptions. I think pretty much all other languages have said, yeah, that was an interesting experiment, but didn't really work out, so we'll have exceptions. We might even have exception specifications, but we're not going to enforce them because it just it doesn't scale. In small examples, it seems like a good idea, but when things start getting bigger, it just adds more mess than you get benefits from. So obviously, Python has deeply integrated and relatively efficient exceptions relative to Python in general. And I was kind of stunned when I discovered that even the end of an iteration for loop is reported by throwing an exception under the covers, so you can actually go in and catch those if you want. And so you go, oh, wow, that's different than the way we thought about exceptions in C++, where you didn't want to throw an exception unless you absolutely had to, unless things went really wrong because it was expensive. And that premature optimization thing colored my perceptions for quite a while. But then when I saw this, as in many things in Python, I realized, oh, I was thinking about this in a too constrained fashion. Even PHP has exceptions for error reporting. So this is a great model. This is terrific because all you have to do is learn exceptions and you have the one true answer. And if the house is, yeah. So, well, except there's a couple things. There are often overhead for exceptions. Regardless of how you do it, you end up collecting a whole bunch of data and throwing it through an alternate path. More importantly, I would say the programmer overhead for both writing exception code and reading it. It doesn't mean that it's wrong. It just means that using it everywhere, as Java decided to do, the unified approach, it was overkill, as in many things in Java. Yeah, I know. It's ironic. Anyway, so it's not, more importantly, it's not always appropriate. It doesn't, there are a number of different issues. When you get into trouble, if you panic and throw everything away, you often lose some very valuable and expensive calculations. And just because somebody somewhere throws an exception and you don't happen to catch it, that could, I worked on a project that it required days to get through a simulation. You don't want to be throwing an exception in the middle of that. It's also a problem because exceptions basically jump you into a different context. And so that's not always appropriate. Process boundaries is a big issue in many languages because if you have a process, exceptions really don't cross process boundaries very well, if at all. So what if you have many processes and one of them throws an exception? What do you do with it? You can't really let it out of the boundary. It's a mess. And often, the exception is you can typically only have one at a time in your whole system. It depends on the language and the system and stuff, but that's often the way the model works. And so as we move into the realm of concurrency and multiple cores and things like that. It doesn't really scale very well, again. Okay, so let's look at the Go language, which is really the first place where I saw this kind of alternative way of doing things. Initially, they had no exceptions, and later they added, I think, very carefully worded panic and resume. And so panic doesn't, exception, we get used to the idea of, oh, I take exception to that. Panic is a much stronger word. It says, hey, something really bad is happening here, and you don't panic when the dog piddles on the carpet. So most people don't. Anyway, so the way Go works, and the Scala is the same way, and it's we're seeing this pattern a little more where you say, okay, I'm going to define a function. Here's the function name. Here's the argument list, and following that is the return type. All right, so it turns out that it works better for a lot of reasons. Notice here the return type looks like you might recognize something that looks like a tuple in Python. Yeah, we're clumping some things together. It turns out that Go doesn't use tuples in particular. This is just multiple return values. But for our purposes, it looks like a tuple. So it doesn't actually pack things into a single object that you unpack. It just passes more than one thing. So here is an example of a call to this open function, give it a file name, and it returns two values. Go uses type inference when it can, and the colon equals that we see here says I am defining as well as initializing f and error. So what this says is, here's the return value, here is the error value, and so all I have to do is check the error value. If it's not nil, I've got an error. So it kind of at least guides me in that direction. I know I've got two things. I know one of them is an error object, and so all I have to do is check it. This is the level of simplicity of what I'm talking about here. You return two things instead of one, and one of them is an error object. Scala has a bunch of different ways. Scala is kind of a, it went through a lot of experimentation, and I think this is a good thing, but we see some artifacts which people have used, as in this case, they have used for error checking, and then it's kind of left behind, and it's a little curious. This atomic test this example is from this new book that we're coming out with. An atomic test is this little tiny test framework that I created for that, so I can say, this thing is that result. So that's all there is to it. That's what that's there for. So again, we have I'm declaring that I'm defining a function. Here's the name of the function. Here's the argument list. And ordinarily, we might have a return type, but Scala has a lot of type inference. So it has this kind of Pythonic feel to it that way. So, so I didn't declare a return type because type inference will take care of it for me, and I tend to be kind of minimalist. So if I is equivalent to 0, I return left. And if it's okay, I return right. This is just a convention. Left and right those are the objects for either. And so either is for, well, I have two possibilities. So people took this and they started using it for error reporting. And left, being the sinister traditionally, will say that that's when something goes wrong, and right is when everything is right with the world. So, and Scala is an expression-oriented language. So this is actually returning this value. There is a return keyword, but you don't have to say it if it's just the result of the expression. So the result of this expression is either left or right, and the expression is the definition of the function. We have the equal sign between the declaration and the definition. So I test this using what's called pattern matching in Scala. So I call the function and I match it with, and pattern matching is kind of the case that grabs a lot of people and say, oh, that's so great that I need to change to this language. So I match with either a left object or a right object, or you can match with basically anything. And so that's what makes pattern matching so powerful. So I look for left or right, and this gives me results. Well, that's all right, but I didn't like the left and right. I'd rather have clearer names for these things, and in Scala 2.10 they introduced this try, which would produce a failure or success object, and that was okay, except it returned the whole stack trace with it. And so I wrote some code so that I could simply say fail rather than failure, but use their success. And so it looks just like the left and right, except that now I have names that are more meaningful for me. So I like that better. And this is some extra syntax that they added, which I'm not going to go into. The basic idea is there. So let's look at how would we do this in Python. Let's start with the idea of a tuple, which I'll return a tuple as a result, and I'm just going to check the time here. Yes, okay. I want to return the tuple as a result, and so here I'm returning the first element of the tuple as the success value. False means there wasn't a failure. And in the case of a failure, I'll say, well, I won't return anything, but I'll return a true. So a simple flag indicating success or failure. And then when I test this, I call it, I catch the tuple values, and again, I'm kind of forced to do that. If I didn't, it would be, I couldn't really ignore it. Here's my, okay, so I test it, check it, not bad. Well, so that didn't feel, I don't know, I wanted to further explore it. So suppose that we create a result class, and from that we inherit a fail. So we'll say if I return just an ordinary result, that'll be the success, and you'll actually put the result in here, and I've got a default argument for fail, which is false, and then I'll inherit from that, and I'll give it a reason, and the default for reason will be true, or I can stick an explicit reason in there. So now I can just return the result here for success and fail, just like I did in Scala. So I kind of like from a readability standpoint, I kind of like the syntax for that a little better. And here we have to, we take the result, and since it's an object rather than a tuple, we have to ask it, did you fail? And otherwise, I pull out the result. So not so bad. I could also do an is instance. I could see, is it a fail object? All right, so I'm liking that maybe a little better. One thing I'd like to do is maybe slap you if you're not using this right. So if you access the result and it has failed, I'll put a getter on there, and so I can make sure that fail is false before I allow you to return it, to get that value. Otherwise, I'll raise an exception. And so that's a small modification to that idea. And let's see, is there anything interesting down here? Yes, well, again, we use it in the same way, but if you call it and you ask for the result without checking, then I'll throw an exception. So that seems a little better. Finally, we can package that up into this result, and it makes sense if I'm throwing an exception. I'll make a separate class for that exception, and then everything else is basically the same, except that down here I throw one of my result errors if it fails, or if you behave badly. So now we can use this by simply importing. Then I can return my result or my failure. And so it's a simple little library, but you can look at the code very easily and see how it works. And one of the things at this point, because Scala is a functional language, it's got me moved much more into that space and trying to figure out, what it is and how it works. And one of the things you do a lot in functional languages is the composition approach and composing smaller functions into larger functions. And so would there be some way that we could do like mapping print onto this function and have all this stuff taken care of? It turns out that if you go to this talk on InfoQ, the person is trying to describe the idea of a monad, which captures all of this stuff, but he's using Python. And it gives you a kind of an idea of how you would do more functional stuff within the Python language. Also, C++, even though it's still holding on to doing its own memory management everywhere, it is moving in this direction. And if you go to this channel9.msdn.com, look for one of the kind of lights in the C++ world, Alexandrescu, and look for error, you'll see that they're doing pretty much exactly the same thing, combining success and failure objects to report return values. So at this point, I can take questions. And oops, let's make this guy, my little question guy, bigger. So yes.
There's a microphone over there, or come up around here. Come on up here, and you can use this one.
All right. All right. So
I wonder if you could just go over again for us the reasons why this is just better than standard exceptions that we're all used to.
Well, okay, so at least from my perspective, there's a difference between error reporting and just panicking and grabbing the stack and blowing it up. And so the idea of this is for certain, well, for example, you wouldn't necessarily throw an exception when you could log an error. So sometimes logging is the appropriate thing to do. Sometimes simply reporting it is the appropriate thing to do. And then when things get really bad, you throw an exception. It's because we need a collection of different approaches for handling errors.
So, hi, Bruce.
Oh, Alex. Oh,
you turn that mic on?
This is going to be bad. Can I just give up right now?
Well, the mic did before.
Oh, thank you. Thank you, whoever turned his mic off. I appreciate that.
I'll handle that exception, will you?
I would never.
Why did you deliberately make the last result class unable to hold a result of 0? I don't get it. You deliberately set it up to raise an exception if the result is 0.
Oh, not if the result is 0, if the argument is 0. In other words, it was just, I didn't go into enough detail. I'm just preventing a divide by 0 error. I'm saying you pass me a 0, I'm going to divide by...
No. Can you please bring the code up again? The last... yeah, right. If self under result, blah, blah, blah. So if this is encapsulating a result of 0, it will raise an exception. I don't get it.
Oh, thank you. That's just stupidity on my part. See, I knew he was... Yeah, this is version 0.1, so obviously I need to check for none instead. Thank you. Yes.
Hi. One of the issues that you mentioned with exceptions was crossing process boundaries. I was just curious how you would approach this, or what pattern you're envisioning for this in terms of the result you're having is essentially a tuple, or what do you see as far as implementing this?
The problem is if you start a new process running something in it, and that process throws an exception, the exception really doesn't have anywhere to go. So basically, we don't want to throw exceptions inside of processes. We want to always be checking the results and not rely on the exception mechanism. That's what I obviously badly was saying.
Hello.
I think it's working.
Yeah. The idea which you said, which is interesting, that when we raise an exception, the languages lose a lot of context after the exception. So I'm not sure if Ruby seems to have this construct by name retry, which the first time when you come across so in the try except block, there is a statement by name retry. The first time when I came across it, I found it like it's like a hammer for the exception. But from the context which you say that, okay, you're losing a lot after the exception, so the retry seems to be like having that context to go back and do something else. Do you have any ideas on that?
Yeah, I know. See, that was something that the C++ committee struggled with, and any sort of resumption. Basically, if I understand that correctly, it's a resumption mechanism. And at least in the C++ committee, they decided that resuming, and they did this based on looking at historical other, I think Modula 2 or something was trying to do something like this. And what they discovered is that nobody ever seemed to be able to use the resume mechanism. Once you threw an exception, it was too hard to get back. And maybe Ruby's works better than Modula 2's or whatever. Anyway, I haven't really explored the resumption that much, other than because I was biased by the discussion in the C++ committee. Thank you.
Go has this function where it'll change behavior of the functions depending on how you'll choose to handle the errors, like whether you even accept an error return. I think this paradigm doesn't make much sense in Python, but I was wondering how you think this will fit into kind of the evolution of error handling.
I don't think I understand. This may be an aspect of Go I haven't studied yet. Is this a newer thing or just something?
I think it's only in certain parts of the core language. But for instance, if you're reading from a socket, if you accept an error, if you if you receive the error, it'll block, and if you don't receive the error, it won't block. Or other way around, I think.
Okay. Yeah, I'm going to say you know Go better than I do.
Okay.
Sorry.
I think if I were going to code this, I would do it a little bit differently. Maybe you can talk about the differences. I think you can save yourself at least 8 lines of code there by simply having the fail class not have a result attribute. And so when you try to fetch it, you get an attribute error rather than having to create a custom error saying you shouldn't have tried to access this.
Yeah, you're probably right. The reason I put it in was, and possibly this was coming from the way Scala did it, was that if you wanted to add extra information, you could put it in there. That was, yeah,
okay.
Assuming I understand it. So it's, yeah, optional extra information.
Okay. Actually, I think you might have just answered my question. I guess with the exceptions, I guess they also come with a stack trace, so if you wanted to see what happened, you could find that out, and you could also tell, like, you could put into the exception, like, oh, the DB crashed, or we timed out. So how would you do that with this method?
Right. Well, the idea of this is that you don't want to, what you're doing, you don't want to know all that information. You just want to know whether it succeeded or failed or why. And if you still needed all that information, in other words, if it was more of a disaster than simply, hey, you gave me bad inputs and so I have to return error information, then it's not necessary. And in fact, in Scala, I was able, the reason I could get my little library to work in Scala is that they had a no stack trace option, because otherwise it was too heavyweight to be returning all of that stuff with every method call, function call. Yes.
Hey, Bruce. So one of the advantages, I think, of exception model is that the error could be far removed in the call stack from the thing that can actually handle it. And I'm wondering, just sort of in practice, whether error code checking requires you to sort of all along that call stack to continually pass back the error code until someone can actually handle it, and whether that's a common, programming model, or if it's a problem or not a problem in practice.
Yeah, no, that's a good point. When you have that much separation and disconnect, then it probably makes more sense to fall back on exceptions. But we're talking about places where we can know, like when I call this function, I can know right away whether that succeeds or fails. And it is, again, more, did I get inappropriate inputs? Whereas you're probably talking about things where something really unexpected happened, or maybe the inputs came from some uncontrollable place. Yeah. And so, yeah, it is actually unexpected, and then you have this disconnect, and then an exception. So this system, what I'm talking about here, does not remove the need for exceptions. It just says, let's let's have a collection of approaches to handling errors in our toolbox, and this would be kind of the simplest one, and then you fall back to things like logging or preconditions and postconditions, you know, a bunch of different things like that. And so this basically just adds something to your toolkit. And I think it also helps keep the code cleaner for the reader of the code.
That makes sense. Thank you.
Yes.
All right, thanks very much.